Earlier this month, a major explosion occurred at Indonesia's Lewotobi Volcano, specifically at 11:05 a.m. local time on July 7th. This massive volcanic explosion represented the beginning stage of a several-hour-long eruptive sequence that represents this particular volcano's largest eruption on record. This eruption would end up just barely being assigned a lowermost score on the Volcanic Explosivity Index. Well, thanks to being given permission to show this footage, I now actually have footage to share and analyze of that eruption's first moments, albeit starting around 10 seconds into that first explosion. This footage was filmed nearly 15 kilometers northeast of the eruption site, just so you can understand the massive scope of what we are looking at from a distance. The initial explosion was truly massive in scope. Within it, you can even see a particularly large thrown volcanic block that I am guessing was at least car size, if not larger, falling a full half-mile away. But you can also spot the impacts of hundreds, if not thousands, of other volcanic blocks via the small plumes their impact created, especially on the northwest segment of Lewotobi's neighboring Perempuan cone shown here. But then, due to material too dense to rise on the buoyant column of hot air in the eruption plume, portions of the plume collapsed back to the ground, generating several hundred degrees Celsius pyroclastic flows. One lobe of the pyroclastic flows shown here I measured to be advancing at a speed of 177 miles per hour or 285 kilometers per hour. However, this velocity decreased over time, although it did travel a whopping 2 kilometers in only 25 seconds. Thankfully, these pyroclastic flows did not cause any deaths or injuries, nor did they seemingly reach any new structures unaffected by prior subplinian eruptions since November 2024 began. This can largely be owed to the 6 to 7 kilometer exclusion zone surrounding the erupting Laki-Laki cone in all directions, which nearly 3 weeks later is still in place. These pyroclastic flows, which occurred across 2 distinct phases of the eruption, would end up scorching an area of 13.85 square kilometers or 5.35 square miles, reaching as much as 4.5 kilometers from their origin. Before I go back to analyzing the prior footage, you might be wondering why the fact such a large area was quickly incinerated didn't ignite a firestorm or massive wildfire of sorts. The reason is in fact that 98.9% of the area impacted had already been scorched by a series of up to 4 other voluminous pyroclastic flows, with the July 7th eruption, despite being the largest in terms of tephra volume ejected, actually ranked 4th of 5 among extent of pyroclastic flows it created. This is how those pyroclastic flows compare to the active exclusion zone, all completely falling within it. Now, looking at the rising eruption plume, I calculated that it for a time was rising at a velocity of around 60 miles per hour, which for a highly explosive eruption is actually unusually low, so my estimate here might be incorrect. Regardless, you might note how the edges of the upward moving eruption plume are actually rotating vertically, rotating towards the inside of the plume. This motion is in fact caused by cycling warm air inside the plume interacting with cold air below it. Jumping ahead around 15 minutes, by this point the pyroclastic flows have ceased and their deposits have settled somewhat. Yet, due to the hot air they emitted, they created their own low-lying plume, which is known as a phoenix cloud. You can clearly see this cloud obscuring Laki-Laki's summit in this clip. At the present, Lewotobi is continuing its eruptive cycle, currently in the stage where it is growing as lava dome. You can see what might happen next, and I want to quickly note that Lewotobi's eruptive cycles are occurring faster and faster. If we count the multiple major November eruptions as one event, then it took 131 days until the next subplinian phase. But then, it only took another 89 days, and after that, 20 days. Now, this apparent trend could be a fluke, but maybe this is suggesting an increased magma supply as of late. If this were to be the case, in my opinion, Lewotobi could produce another major eruption sometime before the end of this August. As a final note, I would like to thank my new YouTube channel member Greg Palmatier for supporting my work.